Holy hot dog, we are now stepping it up to inequalities, which rational inequalities are actually very similar to rational equations, but we have to deal with an inequality, which inequalities require number lines. So we're going to have an additional piece when we have a rational inequality, but pretty much the first part is pretty much the same thing as when we solved a rational equation. Okay, so the first step, you guys, so our example 4 will be 8 over x plus 5 is less than or equal to 4. So let's find out how to solve this amazing, incredible, wonderful, stupendous problem. Let's see how it will go. Okay, so the first step, you guys, is to find the LCM, and guess what? It's the same as what we've been doing. Okay, so our LCM, we look at all the denominators, which the only denominator I see is x plus 5. Okay, and this actually makes my life easier because when we find the LCM, we just grab one of every different thing that we see in the denominator, which since I only have one thing in the denominator, that's the only thing that will be my LCM. So guess what, you guys? My LCM is simply x plus 5. That's it. Bam, x plus 5. Okay, which if you want to put in a parenthesis, you can. It doesn't matter, though. Okay, so my first step is done, so bam. Next step says to find where the LCM is undefined, and that's just like what we did before. Now, when we find where the LCM is undefined, this is going to be one of our critical numbers, which critical numbers are going to end up going on our number line. So we're going to be finding two different critical numbers that go on our number line, which will help us to figure out what our answer is going to be. Okay, which our first one is going to be from the undefined. Okay, and I'll talk about this little tidbit in just a moment, but you'll have to wait on that. Okay, so I'm going to set every single factor in my LCM not equal to 0, and that will give me my undefined. Okay, which this is actually easy, you guys, since I only have one thing in my LCM. That means I only have to solve for one thing in my undefined. So let's go. So I have x plus 5 cannot equal to 0. Okay, and I just need to solve this thing. So here, the way I bring positive 5 to the other side is by subtracting 5, because that's the opposite. So 5 minus 5 cancels out and turns to 0. So I'm left with x cannot equal negative 5. Okay, so this is going to be one of the values that I place on my number line, but I'm not going to do it yet because I don't know what the other number is. And remember, we always have the smaller number on the left-hand side and the larger number on the right-hand side. Okay, so I'm going to put that on hold. And do not forget, you guys, since this is where the function is undefined, this is a value that does not work because it makes the denominator 0. Because that's the case, when we put it on our number line eventually, we have to make this value an open bubble every single time. Every time. Because this is a value that will never work. Okay, so when I put this number on the number line, it's always an open bubble. Now the other critical value, the other number on our number line, that will depend on what your original inequality is. But we'll talk about that in just a moment. Okay, so the next step, so we got step 2 done, so bam, done. Alright, step 3 says to make the inequality an equation and solve. So we're going to turn this inequality sign into an equal sign and solve this thing like we would a normal equation. And once we solve it, this will be another critical value, which means it goes on our number line. Holy hot dog, right? Okay, and this one depends on our original symbol, whether or not it's an open or closed bubble. So like if this is not an equal to symbol, since it can't equal it, would be an open bubble. But since this is an equal to symbol, this is going to tell me that my second critical value is going to be a closed bubble. This right here tells me my critical value will be a closed bubble. So I'll kind of keep that in mind as I'm solving. Okay, guys, let's go. So I'm going to turn this thing into an equal sign. I'm just going to pretend that it's an equation for right now. Alright, so we're going to have x plus 5 equals 4. And again, we're just pretending that this is an equation for right now. Okay, and then we solve this like we would a normal equation. Which if you guys think back to those original equations that we solved, remember we take the LCM and we multiply it to every single numerator we see. Okay, so I'm going to multiply x plus 5 to every single numerator. And remember, the goal is to make our denominators disappear. We're going to be little math magicians. Let's go. Okay, So right here, I see an x plus 5 here and here. Holy hot dog, they cross out. Cancel out turns to 1. So I'm left with 8 equals, and then here nothing will cross up, but guess what, you guys? We don't have any denominators that need to be canceled out. So I'm left with 4 times x plus 5. Okay, which I'm going to go ahead and distribute. Since nothing's crossing out, let's just go ahead and distribute this thing. So 4 times x will give me a 4x, and 4 times 5 will give me a 20. Alrighty, let's solve this thing for x. So remember, we wait for division and multiplication at the end. So I'm going to start with my addition and subtraction, and the way that we move a positive 20 to the other side is by subtracting that thing. Which 20 minus 20 cancels out and turns to 0, and 8 minus 20 is negative 12. So what I'm left with now, I'm going to write it over here since I have some more space. I have negative 12 equals 4x. And the way that we get x by itself, since the 4 is secretly multiplying to my x, the way we move that bad boy to the other side is by dividing by 4. So 4 divided by 4 cancels and turns to 1. And negative 12 divided by 4 is negative 3. So on this side, we're left with x equals negative 3, which this is another critical value. And since this is equal to up here on my number line, this bad boy is going to be a closed bubble. But remember, my undefined is the other number that goes in my number line, but since it's undefined, which means it can never exist in this function, I have to make this one an open bubble. Okay, so this one is going to be a closed bubble on my number line. All because of that sign right there. And this one, no matter what, in your undefined, this bad boy right here is always an open bubble. So now, let's focus on the number line. So we did all that. So now I'm going to place numbers on my inequality. Okay, I'm going to place numbers on my number line. And then we're going to test them back into our original inequalities to see which section is going to be shaded. Okay, but before we do that, let's figure out what goes on our number line. Okay, so the smaller number goes on this tick mark, which out of these two, which one is the smaller number? Negative 3 or negative 5? You guys are too cool for school. It is negative 5. That's the smaller one, so it goes on the left, and the larger one is negative 3, so it goes on the right. Okay, and remember, you guys, I already know that my negative 3 is a closed bubble, and my negative 5 is an open bubble. So I'm going to go ahead and do that before I forget. So I know it looks a little weird, but it is okay to have one bubble be open and one bubble to be closed. It's okay, you guys. Okay, so what we're going to do, remember, if you think back to the Prezi slide, okay, my answer either is going to be an and or an or. So I have to figure out which regions I'm going to be shading in. And what I'm going to do is test values from each of these regions, which I'm going to call these regions 1, 2, and 3, or my first, second, and third interval. I'm going to test values from this section, and this section, and I'm going to substitute them back in here to see which one of these will give me something that's less than or equal to 4, because that will make my inequality a true answer. And depending on which one works, it's the one that I'm going to shade. And my answer should be an and, so it should be either these two out here shaded, or it should be mixing them up, you guys. It should be an and, which is this middle one right here, or it should be an or, which are these outer two regions. So it's either the middle one, which is an and, or the outer two, which is an or. Let's find out, because I know you guys are dying to find out which is which. Okay, so for my first interval, let's focus on this section right here. Okay, which these things over here, okay, let's think. These are things like negative 6, negative 7, negative 8. So these things are smaller than negative 5, and we can't equal negative 5 because it's an open bubble. So my first region is x is less than negative 5. Okay, so that's my first region. So I need to test something that's less than negative 5 back in here and see if I get something that's less than or equal to 4. So what's something that's less than negative 5 that I could test? And guys, the smaller number that you pick, the easier your life will be. I'm just saying. Okay, so the smallest thing I have closest to negative 5 is negative 6. So I'm going to test negative 6. Let's see if that works. Okay, so I'm going to test this back in here. I'm going to substitute a -6 for my x, and I'm going to see if it gives me something less than or equal to 4. Okay, I don't care about this anymore. All this told me was, what am I going to test in this inequality? Okay, that's just telling me what I'm testing. This is not what I'm solving for. So be careful. The demon cats like to tell people you're solving for a -5. Okay, but I'm actually solving to see what gives me something less than or equal to 4. All right, guys, let's do this thing. So I'm going to test -6 back in here for my x. So I'm going to have 8 over, my x is going to transform into a -6 plus 5, and I'm going to see if it's less than or equal to 4. Let's see what happens. So again, 8. Whoa, my 8 just got all messed up. Sorry, guys. 8 over, my x is going to transform into a -6. So 8 over -6 plus 5. And I want to see if this is less than or equal to 4. So this is what I'm testing. I don't know yet. It might not. If it doesn't work, I do not shade that region. But if it does work, I do get to shade this region. So let's see what happens. Okay, so -6 plus 5 is -1. So we have 8 over -1 is less than or equal to 4. Which 8 divided by -1 is -8. Let's see, did it work? I don't know. Let's see. Is -8 less than or equal to 4? Holy hot dog, it is! Yay, it works. Okay, so my first region will work, so I get to shade it. Yay. Awesome. So I already kind of know maybe what my answer could be, but it does not hurt to go ahead and check all my intervals because it's really easy for you guys to make a mistake. So even though we kind of already know, since I shaded one outer region, that it's probably going to be this one, it does not hurt to check because we are not perfect mathematicians and we make mistakes. So I'm going to check all the regions. And on your test, I do want to see you check all the regions. So don't take the shortcut and only check the ones where you think it'll work. Okay, so my next region, these values are things that are in between -5 and -3. Okay, so in this region, okay, these numbers are going to be larger than -5, but we cannot equal -5 because of this open bubble. So x will be greater than -5, but x will be less than or equal to -3 because these things in here are things like -4. -4 is smaller than -3 and larger than -5. And on this side, we use an equal to because it can equal it because of our closed bubble. All right, so what's something in between -5 and -3 that I could test? Well, look there. I think -4 is a good option. What do you guys think? I think so. So we're going to test x equals -4. And again, we're testing this value from this interval. That's all we use this for. So as of this point, I do not care about this interval anymore. Okay? But we're going to test this back in here and see if it gives us something less than or equal to 4. If it does, I get to shade. If not, it does not work. It super fails, and I cannot shade. Okay? So let's see what happens. So I have 8 over my x right here is going to transform into a -4. And I'm going to add the 5. So -4 plus 5. And I want to see if this thing is less than or equal to 4. That's what I'm testing for. So I don't know yet. I have to solve though. Let's see if it works. So -4 plus 5 is 1. So 8 over 1 is less than or equal to 4. Which that is 8 is less than or equal to 4. Is 8 less than or equal to 4? No! It is not. This one super failed. Oh no. Okay, so this region did not work, so I cannot shade it on my number line. Okay, so this one is not going to work. Bam. Bad interval. It did not work. Alright guys, let's see what happens with this final interval. I have a really good feeling about this final interval, so let's see what happens. Okay, so my final interval, these are things like -2, -1, 0, etc. Okay, so this is where x, these things are larger than -3, and it can equal -3 because we have a closed bubble. So x is greater than or equal to -3. So let's see here. I want to test something that is greater than or equal to -3. And guys, it does help. If you see here we have a fraction, you probably want to pick an x that will easily work out so you can divide 8 by it. Like if I picked 0, 0 plus 5 is 5, and 8 is not really, well, it's divisible by 5, but you don't get a pretty number. So we want to think of a number that will give us something pretty and something that will work. Okay, so something in here that I have a good feeling about, I think -1 is going to work out. Let's see what happens with -1. So I'm going to test -1. Why not? I can test anything in this section, and I think -1 will give me a prettier answer. So let's see what happens. Okay, so what I have, I'm going to transform this x right here into a -1. So I have 8 over -1 plus 5. So 8 over -1 plus 5 is less than or equal to 4. Alright, let's see. I don't know yet if it's less than or equal to 4, but let's see what happens. Alright, so -5 or -1 plus 5 is 4. So we have 8 over 4 is less than or equal to 4. And do you see how this is going to give me a pretty answer, because 8 is definitely divisible by 4. So -1 was an awesome choice, you guys. You are so smart. So 8 divided by 4 is 2. Let's see. Is 2 less than or equal to 4? Holy hot dog! It is! Yay! It works! Okay, so this one will also work, so I get to shade it in. And since my arrows are going in opposite directions and are not colliding, my answer is an OR. And guys, it's really important to write these from the get-go, because guess what? These are going to be your answer at the end. So my answer are these two intervals will work. So when you guys write your answer, I do want to see a number line and I want to see these inequalities. So my final answer is going to be x is less than -5 from here. And since my arrows go opposite ways, I know this thing is an OR. So it's x is less than -5 or x is greater than or equal to -3. And that, you guys, would be my final answer. Wasn't that exciting? I love rational inequalities. They're just so much fun. And I know you guys are pumped up for the next example problem, which is right here. So go ahead and pause the video and watch example problem 5. And you can just see how much fun we're going to have in just a moment.